All right, class. Today we're going to work on solving systems of linear inequalities. And if you understand graphing linear inequalities, this will be pretty simple for you. All right. First, you have to graph the line and appropriate shading for each inequality on the same coordinate plane. So just like when we graph system of linear equations, where we graph two lines on the same coordinate plane, we're going to graph both inequalities on the same coordinate plane. Now, we have to make sure we pay attention to whether we have dashed or solid lines. So remember, if it's less than or greater than, you're going to have a dashed line. If it's less than or equal to or greater than or equal to, you're going to have a solid line. And just so we understand, a dashed line is going to look like this when you're creating your line, and a solid line is going to look like that when you're creating your line. Now, this is one of the most important aspects of what we need to understand. The solution is the section where all of the shading overlaps. Now, it will help if you use different colors, color pencils when you're doing this, or if you use a pencil and then a pen when you're doing your shading. That way you understand. For the examples I'm going to do right now, I'm going to use two different colors so that you can see distinctly. All right, so we look at this equation. We have y is less than or equal to 2x plus 1. So I'm going to graph this line first. I have start at 1. My slope is 2 over 1. So I'm going to rise 2 and run 1 to the right, up 2, 1 right, up 2, 1 right. I'm going to go in the opposite direction as well. Down 2, 1 left, down 2, 1 left, down 2, 1 left, down 2, 1 left. And now I pay attention to, I see that I have a less than or equal to, so I am going to use a solid line. So now I'm going to make my line. So that is my line. And now I'm going to do my shading. I'm going to pick the point 0, 0. I'm going to plug it in and see if it's a true statement. So I have 0 is less than or equal to, basically 2 times 0, I know it's going to be 0. 0 is less than or equal to 1. That is a true statement. 0 is less than 1. So I am going to shade this area over here. And it doesn't matter how you do your shading, just as long as you understand that is the area that's being shaded. Okay. Now I'm going to look at the second equation. Y is greater than negative 2x plus 5. So I'm going to have my y-intercept is at 5. And then my slope is negative 2 over 1. So I'm going to go down 2 to the right 1. So down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1. I'm going to go the opposite direction, up 2, left 1, up 2, left 1. And now I look and I see, because my sign is just greater than, I have a dash line. So I am going to go that way. So you see my line goes through the part of what I already have shaded. Now I have to figure out where my shading goes. So I'm going to plug in 0, 0 because I'm not on that point again. And if this is a true statement, I'm going to shade on this side. If it's not a true statement, I'm going to shade on the side that is over here. So I have 0 is greater than 5. Is 0 greater than 5? No, it is not. So I am going to shade this area over here. And now my solution set is the area where my shading overlaps. And I'm going to outline it in green here. So here and all of this area right here. All of that is my actual answer. So that means that every point in this region that's outlined in green will be a correct solution for this problem. Okay, and that's all I have to do in order to graph systems of inequalities.